Welcome to benchmarking virtual mesh storage systems. Me and you. Friendly it is. Sure, 5 more people come scrolling in. They will have to pick up whatever pieces they missed. Right. Coming into the movie late means you missed the beginning. Yeah. Oh, yeah. Benchmarking virtual storage systems is a subset of benchmarking virtual systems. Right. I'm sorry, I should introduce myself. Bob Gezelter, I'm your speaker today. I've been doing VMS since, well, 1.0. My first machine was a 780. Before that, I did RSX. Benchmarking virtual storage is a subset of benchmarking virtual systems. Problem is, for the reality of benchmarking a virtual system is, what do we really know? Well, if CPU ID tells you you're on a microfax 2, let's say, hypothetically. Really? It could be anything. This is, if you're like the original Star Trek series, Spock's brain. You could be connected to your body, or maybe not. The disk may or may not be what it says it is. The memory capacity may or may not be what it is, and the speed may or may not be what it is, and they may be competing consumers of CPU resources. So the picture you see may not be what's there or what's available. It's perfectly possible to have 2 machines show the exact same configuration from within VMS and be performing completely differently. That represents a problem. When you are a systems manager doing benchmarking on a virtualized configuration, you need to call out every detail of the underlying configuration. And even that may not save your life, because you don't control the competing things on the same box, the same SAN, the same network. Nor are you aware of what's happening in many cases. You don't know if a gap in timing between 2 network packets is caused by the far side virtualized system responding slow, or the switch is saturated on an intermediate link, or there's a bad cable on the intermediate link, or another client machine on your machine, another VM client on your machine or the remote machine is causing a CPU starvation problem. All are completely possible. And that's not even counting storage. That too can have competing resource allocation problems. So one has to take benchmarking with a lot of care. Because unless you can standardize the conditions, the results are not reproducible without making sure you're in the same state. We're used to thinking of mass storage as disks. They rotate, they have heads that seek. When you start changing these presumptions, even though the data reported to VMS is the same, maybe not. And therefore, once again, you have to be careful. If you're a vendor and you're publishing performance numbers, you need to understand the limits of what you're saying. Because if you put down a performance number in a document for a customer, that's legal. You can get sued. I have seen it happen. If you don't actually understand performance, you can't do benchmarking. Sloppy benchmarking is dangerous operationally, It is dangerous legally, and it is dangerous commercially. If you're a vendor and you sell a system and you state certain benchmarks, the judge does not want to hear that, well, it was a different configuration. The question will be, did you set up the configuration? Yes, sir. Well, then that's your problem. Nor will business interruption coverage cover you in that case. Modern mass storage, the only thing you're guaranteed is it's block addressable. Whether it is compressed or not, no clue. Is it RAM, SSD, spinning disk with a cache? No clue. Some disk drives that are physical still come with multiple cache sizes, submodel numbers. No clue. If it's behind a cache, solid state, I got everything. Deduplicating. The behavior of a deduplicating mass storage system will not be the same as a straight storage system. I was just talking with lunch to a colleague. Imagine running a test, take a file, you initialize it using a standard initializer to a fixed binary pattern. You now push that file to a deduplicated mass storage device. You look at the first block or first whatever the unit of compression is, say, yep, noted it, computed the SHA-256 or whatever it's using, looks at the next block, same thing. I don't need that anymore. Next. That runs at bus speed. I'd write out one signature. Yeah. Or, well, not one. Write out a bunch of signature index number references. It can be. It doesn't matter. You get a call from somebody arbitrary about performance, and like a physician in an ER or a triage nurse in an ER, you have to ask each one of these questions. And at the end, and note, very important for your livelihood, your employer's livelihood, you have to make sure you write down the answers. Because if this happens and you give an answer which turns out and they gave you the wrong information, that's a different conversation. They may not know. They, for example, may be using a storage. Let's take an example. You use a cloud provider. Cloud providers are frequently set up with the presumption that you're running Linux or Windows. Linux and Windows volumes have lots of duplicate data. So deduplicating arrays were meant for that use case. You can fit a deduplicating array housing 1,000 Windows workstation images for 1,000 virtual desktops. That's a big savings when you think about it. Yeah. But if that's the case, you violate that presumption, the bets are off the table.
Yeah. I can remember back in the 80s and 90s when the database standards would publish benchmarks. So they were always very careful.
They are very, very, very careful.
3 sheets telling you exactly what processor they use, exactly what disk.
You have to. Because much of that is stimulated by governmental contracts, where if you don't produce the same benchmark when the system's installed, you have a serious problem on your hands.
Yeah. Well, it's also beneficial for the person doing the benchmark. Because all they have to do is show that you use something else. It's like, that's not apples to apples.
Yes, but you have to be careful.
Right. Yeah.
You can have hierarchical storage, and that produces very interesting behaviors.
Yeah.
You may have, for example, on one client's device that I'm familiar with because I actually have. Oh, by the way, when you're looking at storage devices, read all the manuals cover to cover carefully multiple times. Use a highlighter. Take notes. There will be an exam at the end, and it can be a brutal exam. The problem is, you will, for example, a mid-range, let me forget the exotic storage arrays. On what is classed as a mid-range storage array, the HP MSA series. These are designed for departmental or small and medium business use. The SMB market, which, by the way, SMB is an overloaded acronym. It means lots of things, some of which appear in the same sentence. This is really confusing. The 2052 that I happen to have to read multiple times to understand how it behaved has a controller cache, possibly plugged in SSD cache, then rotating storage tiers, multiples. So it can have the internal cache, the SSD cache, 15K SAS, 10K SAS or SATA. Why would you buy SATA? Why? Backups. But not backups, not running the backup, but archiving the backup. If it's not used, it'll migrate onto the slower, cheaper disk, which you could buy more of. Performance costs money. Okay, watch what happens then. Let's assume the simple case. Oops, I'm running ahead of myself. Okay, you have different levels. I'm already in levels. You also have the OpenVMS cache. Norm Stovica from SCI gave a good slide set on how to tune the VMS cache and how to set things to bypass and all that. Actually, no cache. Point is, you don't always have all the control levers on all the things you want to have. Remember, if you go down the pile, down the stack, semantic content of the data is lost. VMS knows about files, sort of. When it gets down to the cache level, not so much. When you get to the storage device, all it knows is LBA range and possibly host. Maybe. That may not be reliable in a complex network. When you get down to the drive, all it knows is block requests. It has no knowledge of how this fits into the bigger scheme of things. Absolutely. And these are operating together, and that introduces problems or potentials for trouble. When you do a benchmark, think carefully about what you're benchmarking. I mentioned previously repetitive patterns in dedupe. Oops, you get what happens? You run a benchmark using this huge, say, 20 gigabyte file. You need to model backup. But backup is not constant data. So you get a spurious number. Then you run the real thing, and oh my God, it's not behaving. You said it would take 15 minutes. It did. Eek. That won't work. If you have a cache at multiple levels, and you're writing out write-only data. By the way, I'm not saying write. When I say write-only data in this presentation, I mean write-only within the time window of cache. So if you're going to pull it back next week, that's fine, but the cache is only going to see it once, and after n blocks later, the window will close and it'll throw it out to the next level of storage. This cascades. The storage in the controller is one speed, the storage in the SSD cache is another, the storage in the 15K SAS drives is another. as you hit the various saturation points in a level, you stall waiting for the piece for enough free space to open up. Now, frequently you degrade to the slowest tier available because water goes downhill. CPU, the controller cache maxes, it tries dumping something into the SSD cache, that hits its limit. Therefore, it can't free a block until it gets a block out to the 15K SAS. And now you're running up the speed basically with 15K, you have a pipeline running to the 15K SAS drive at the slowest speed possible. Oops. If you don't understand the capacities and don't understand the capacity of what you're writing, you can very easily give out a number to your senior management saying, no problem, we can do this. It's only, we benchmarked 10 gig and we only have to write 60. We just say 60 amount of time. No, not quite. If the cache at the top was big enough to hold everything, you don't know what's going to happen next. You don't know when you cross that event horizon into the next tier, how the next tier behaves. It gets worse. What if somebody else using the same storage controller is writing to another logical volume? Then you don't have the 10 gig cache you thought you had. You've got some fraction of it. I have never seen a drive controller manufacturer describe the algorithm for arbitrating cache usage. We assume, for purposes of argument, that the cache usage is first in, first out. Least recently used, if you will. That's an assumption. That's not necessarily Holy Writ. There's no way at the virtualized host, the guest, to figure out if there's any cross traffic unless you log into the controller or the network switches and start monitoring. Because every level you can see from the host and the guest is going to be bogus. You need to, when you do benchmarks, if at all possible, you need cooperation from the people supporting the infrastructure to verify that what you think is a benchmark is a benchmark. If you're using a cloud vendor, you won't be able to get that. They will not give you certifications of what's behind the VMs unless you're a very large customer willing to pay a lot of money. What you have to do is assume that that will happen and set your expectations accordingly. If it says 15 minutes, you better allow an hour on the schedule. This is very important when talking to management above technical. All they know is what they were told by the cloud vendor. That may or may not reflect the reality of the time you're trying to do what you're trying to do. So if you plan on something taking so long, it's either small, in which case you'll probably get away with it, or you have to allow really worst case possibilities. Space on many modern arrays can be expanded. They tell you to use that feature. The problem is they also tell you you're free to over-allocate. But they will warn you when you hit yellow warning and you can slam another drive into the frame. Two problems. One, depending on the write rate, that may not be enough warning. You have to evaluate where you want the warning to go off. Two, you may not have a spare drive at that time. You may not be on site at that point. And can you extend the logical volume from the operating system side under the circumstances you're operating? You have to understand all of these, both for provisioning and for benchmarking. If things are happening behind your back, make you feel good, that's not something you need to know what they're doing. And whether you can control it and what the alarms are, it's not. It was simpler when it was just a simple fit in your hand disk. You knew you could see the reality. Here you cannot. And it can be a very dangerous operation. Not in the computer end, but many years ago, after the American Airlines crash in Chicago, DC-10, which took out a large part of Playboy Enterprises' publishing staff, who were on their way to a conference in Vegas. Many companies established a rule that two developers, two executives, could not be on the same airplane.
Yeah.
And they adhered to this for many years with great success. Then a bunch of people had to fly to Geneva from New York. And they found, happily enough for them, that there were actually multiple flights leaving New York at the same time, arriving in Geneva at the same time on different airlines, Delta, Swiss Air, and several others. So they happily booked. Unfortunately, they were code shares on the same airframe. The stereo system caught fire. You do a salt water sensitive insulation on the stereo entertainment system. The cockpit filled with smoke, and the airplane went down several miles short of landing at Gander, Newfoundland, with complete loss of life. Oops. People don't learn. You have to check the redundancy is redundancy. If they say you have two SAN cables and they're both working, you all got to go down and either unplug, cut, preferably dramatically. I use fire axes and wooden blocks. Inspect the interior of the cable to make sure it's working correctly. But you have to be careful with fire. That's a laser beam. That can hurt your eyes. With copper, you can do that. Yeah. Pull the plug out. But part of your standard test needs to be disable one of the alternate path of the two. Disable all but one of the alternate paths in turn and verify that you still have connectivity. Because you may discover they were running on N+1 power. You had N failed power supplies of N+1, which, by the way, is a one power supply system. You may speculate why I say that. I've seen it. I walked into a site with a small storage array, and I almost got a headache. There was a sonar alert screaming at full volume. So I asked the system manager, what was that? Oh, I forgot to silence the alarm. What? I walked over to a storage array. He had a RAID 5 volume, volume A, volume B, the redundancy volume. One of them was bad. He was running non-rated. Oops. You should have seen his boss's face. I walked into their office. You were ordering a spare drive. When? Now! Well, on your credit card, now, FedEx first thing. And that's all he was saying. That's the highest grade they got. But at least get it here now. I don't care. You are running stark naked. You have to be careful. Benchmarking, yes. What happens when you have errors? What is your expected curve? Under what circumstances? You may discover that your beautiful fiber channel network has one of the links running at low speed. When you start, this is not a simple thing. This is tedious to the extreme. Time extends. What is your best case? What is your average case? What is your worst case? Are you, when you run multiple copies of a benchmark, are you contaminating the result on each successive time? Is there persistence? You say delete the file and start over again. No go. Deleting the file may or may not fix the problem. Depends. Why am I saying that? Because you may be deleting, but it may still be in the cache. You're not purging the cache, you're deleting the file. The cache has no concept of file. So you don't know what's there. All the controller sees is blocks. If you delete a file, delete erase will probably work. But if you delete the file and then just recreate the file header, the blocks are still there. The cache at the device level knows the blocks haven't been written. It's going to read and write the same damn thing. Write may work correctly, maybe, but that's iffy. You don't know. And technically, you don't even know if that's valid with a different identical model number part. There could be a different micro firmware rate that checks that optimization and does it differently. Yes, we've seen these things happen. It is not a joke. At every point here, you have cliffs. And resetting for a benchmark is not easy if you really want a reliable benchmark. Once you understand all the intricacy of the path you're testing, you can sometimes take some shortcuts. But you have to know how well behaved the process is in regard to the different variables. Without that, you've got a giant question mark over everything in sight. I mentioned before, resource contention, internal, external, SAN congestion. Now, is it likely? Not necessarily, but the Linux box down the block could decide to do a full bore backup that happens to cross your path, and they happen to have a full capacity SAN fiber channel controller that you don't have, and all of a sudden he's pushing full capacity down the wire and down the cross connect between the switches that you happen to have to get a word in edgewise. What's going to happen? Now, if the SAN group is really on their toes, they'll see it, maybe, if you're lucky. They may not, and you may just be left with an anomalous benchmark. Output save sets are some of the biggest files most VMS sites throw around the system. Number one, there is a particularly poor choice of sequencing with VMS backup, where it backs up the file, encrypts it, and then tries to compress it. Observation: compressed text is white noise. Compressing white noise does not compress. You want to compress and then encrypt the compressed result. This is the way PGP does it. That is the right way to do it. Second, compress is slow, very slow. Using compress to do backups frequently widens the backup window. This may not be acceptable. You can write it, it's not difficult to write a batch job that writes a save set uncompressed and encrypted to a scratch disk and then runs zip to compress it over the ensuing possibly hours. And then shoves the zip archive, encrypts the zip, to encrypt the zip archive and ship it somewhere using SFTP. By the way, the reason you use a zip archive rather than just compressing the backup save set and then using backup to compress it, is that zip files move through FTP and SFTP without problem. And if you're going to be shoveling it onto a file store on S3 or something else, that helps. And you don't have to play with it to make it usable again. You just unzip it. The encryption obviously follow policy if you're storing data, because missing policy on encryption can be a very expensive hobby. If you're HIPAA or financial, you have regulated, mandatory, obligatory standards for encryption and procedures with key management and such. Use them. Violating them will get you an unpleasant experience. Backup save sets. Unfortunately, backup specifies the extend size. I'll tell you a trick I've used. The slide is slightly incorrect. My apologies. I'll try to remember to fix it and resubmit it. If you back up using transparent file access on DECnet, yes, I know that looks weird. You can set RMS in your login.com. You can say if mode equals $interactive, set RMS extend equals 65,000, block equals 255, buffer equals 255. And you will reduce the number of extends and the number of delays by a huge amount. Gargantuan. If you do not do that, you will discover backup using the volume default or your default for extend. And the problem is you don't want to extend, you don't want other files to extend at 65 kblocks a piece. Backup files are unusual in volume. So you want, I frequently do that using proxies. This is proxy login within the node. So it's 0:::, and it works. Do you want to do this? Good question. Will it be supported? You have to have DECnet running at least locally to do it. So it's not a network security issue because you don't have to enable outside links. The performance is fine. It's far faster than doing it locally, doing the file directly, and having the bad extend size. That extend size really hits you. Extends are very expensive. As I said, you want to back up and compress. Backup by default, well, backup does encrypt before it encrypts. Encrypts before it compresses. Not terribly useful. Zip and unzip packet allows you to move the save set over by using SFTP. I will tell you right now, moving terabyte or hundreds of megabytes, the compress is faster in many cases than transferring the uncompressed files over the LAN. Even compressed and zipped down to maximum zip-9, a full disk image of a multi-gigabyte disk will take a while. On a 100K or gigabit LAN, you can probably get 2 or 3 transfers going at a time before you saturate the link. Yeah, I run them in batch because it's too bothersome to run interactively. It's just too tedious. I submit batch jobs to do backups. I actually have batch jobs that submit batch jobs that submit the backups to the scratch pack, which in turn, when they finish successfully, submit the zip runs to other queues that are priority 0 to zip things up, which in then turn shove them across the network using SFTP to another machine which has the storage array attached. It's sort of looking like a volleyball team. As I pointed out earlier, DKN, you two show device DKNs, two different systems virtualized. Even if all of everything display is exactly the same, it doesn't tell you anything. Show dev full will show you the device type simulated. It will not show you the configuration data for the SAN, for the storage array. It just isn't there. Logical volume settings matter. Is the array, the physical storage rated? Which RAID? What speed? These are all completely amorphous questions. You can't see them from the host. What are the controllers? Now, if you really want to be careful, note the controller rev numbers for the storage array controller and make sure you note rev numbers. Yep. Anything can change things. Life can be excessively exciting. The SAN configuration. Jumbo frames was mentioned for Ethernet. Various parameters for fiber channel. Various settings on the switch. Document, 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 document. Because if something goes wrong, you're going to have to explain to somebody. If you don't have to explain to somebody because you're the top of your particular food chain, you're going to have to understand what's going on, which may be worse than dealing with management. Because you need to know what will happen next. Cross traffic is a problem. LAN and SAN with iSCSI coming around. The recommendation, the smart thing to do is put iSCSI on a separate LAN for a variety of reasons, one of them being contention. But in any event, even if you do that for contention, there's going to be cross contention from other nodes on storage SAN. Even with hub and spoke configurations. At some point, it has to, multiple ports have to traverse one switch or one port. And they will jam if there's too much use.
Imagine even when you create three separate logical devices, you don't know if all three of them are actually on the same disk.
It's worse when you have these storage pools that are used on things like the MSA. If you just have a RAID 1 set consisting of two physical volumes, having a whole storage pool, life is easy. Put 4 there, and how the array assigns storage is not documented. And if it's not documented, it's not guaranteed to be preserved across revisions. It'll read, don't get me wrong, it's not going to wipe out the old one, but all it has to do is decide that I have changed the algorithm as to which drive I use. There's so many potential variables here that you're resting on an assurance that the engineering team is benign. They're not going to deliberately, well, that's really too good. Yes. They're not, you hope they're not going to deliberately sandbag. But the fact that they can't deliberately sandbag you makes no guarantee that they don't accidentally sandbag you. So whatever or there may be an exception case related to activity on the drives. It may try balancing drive activity. You don't know.
Yeah.
And therefore, you don't know if you just hit the sweet spot or not. And yes, I'm not giving you any answers. I'm giving you the fact that you have to beware. This is an infiltration course with lots of booby traps. And just because you found 5 types doesn't mean there aren't 6. It ain't over till it's over. Compression is data dependent. Create a 20 gig database, back it up, that's backup. No, you need a 20 gig database populated with typical data. No, see, here's the problem. Typical data may not be the same as data on a day-to-day basis.
Yeah.
You might want to, for bounding, this is all like wet chemistry work. I'm not kidding. This is the same as doing real biochemistry or physics experiments. You have to understand what the range and the variables are. If you have random junk in the name field, write a random junk generator and fill the same thing capacity, take a benchmark. You know nobody did a dedupe on that. Okay? Initialize everything to virgin state, do a backup of that, see how long it takes. Now, fill in large blocks of a smaller population of possible variable names. What happens? Well, if the database is really smart and aggressive, it will dedupe the record fields with a pointer into a hash table. So every John Smith will point to the same literal entry, and therefore, instead of having the expected 40-character field in the database, you'll have maybe 2 bytes, maybe 4 bytes. And unless you have internal data on the database, or it's open source and you'll crack the open source listings, you may never have any clue. So you have to be careful what you're benchmarking. Yeah. You may not be benchmarking what you think you're benchmarking. Time and schedule windows. One trick I came up with decades ago, back in the days of the HSC 50. You have a production database. You need to take a daily backup. The backup takes 4 hours. Okay? But you only have a much shorter time window before you have to be back online. The way you solve this problem is with shadowing. You run 3 shadow members in normal production. At the appointed hour, you disconnect one of the members, remount it privately, mount a scratch disk, join a disk of a volume of equivalent size into the shadow set that's virgin, and let it resync. You can now, once you have it started resyncing, you can bring the database back. You can now, at leisure, back up the member you disconnected. Downtime, maybe a couple of minutes at most, because you're doing an orderly shutdown of the application and database. You're not doing a crash, you're doing an orderly shutdown. You only need the system down in the time it takes to disconnect the member you're going to use to actually back up and the member that you joined. That takes about a minute or 2. You don't have to wait for the shadow to sync. You can, but you don't have to. But the bottom line is that's the fastest way to do it. But you have to have the discipline to do it right, and command files and everything else. It can be done. It is fast. If you have every case is a different case. You get lots of surprises in this game. Things don't always go as planned. The general goal of benchmarking is to produce predictable results in the future. That means you have to deal with all the confounding variables to the point where you can be fairly sure. You have to learn and understand your environment to a very deep degree. You literally have to take a bit and follow it around the system and see where it goes and what gets done to it. Beware sloppy benchmarking, because you'll discover it's not valid. And when you won't discover it's not valid until after you crash, after you hit a wall. I've seen people in the financial biz fail to open for trading or fail to close on time because their benchmarks were wrong. Others, in all kinds of ways, you can miss a deadline because a factor in your analysis was not correct or was more random than you gave it credit for. Thank you much. There's one story, many stories when they used film dosimeters, real physical film dosimeters in radiology.
Yeah.
When you get a new batch, a new lot of film, you run it through the chemistry bath. They had better come out clean. If they don't come out clean, stop. Something is wrong. The next step is you dose a batch of dosimeters with calibration, and you run them through the chemistry. They had better match the reference set. Either your machine is out of calibration or your chemistry is goofed. Or the batches are goofed. They're chemically inert. So you have to make sure that virgins come out virgin and exposed comes out exposed as expected. Otherwise, something is wrong. And all the results you get from that batch, from that setup, have a giant question mark. No difference. You're doing the same thing. And you have to do controls. Otherwise, you don't know what you're measuring. Thank you for attending.
Yeah.
I hope you enjoyed it.